Hello everyone. This video will cover systems of linear inequalities. Okay, now a linear inequality is solved the exact same way a linear equation is solved. So for example, let's say if you have 3x plus 1 equals 7. Okay, so the same way you'd solve it here, you subtract 1 from both sides. You have 3x equals 6. Divide both sides by 3, you get x equals 2. Okay, so this is your linear equation. Now if you have 3x plus 1, and to pick one of our inequalities, let's say is less than 7. Again, you subtract 1 from both sides, which gives you 3x is less than 6. Divide both sides by 3. You get x is less than 2. Okay. Now, the difference is, with an equation, you normally have one answer. Maybe two, depending on if you have a quadratic equation or not, but just for a linear equation, you have one answer. Now for an inequality, and this is your linear inequality, you have an infinite number of answers. You have x can be less than 2. So x could be 1, 0, -1, -2, -1,000,000, -1 billion. It could be 1.9. As long as it's less than 2, it will be true for this value. Okay, so let's start off with our first example describing the system. Okay, so for our first example, we want to determine if the ordered pair 1, 1 satisfies the system x minus 8y is less than or equal to 9, and -7x plus 5y is less than 4. Let me focus this a little bit. Okay. Okay, so to solve this one, we have our ordered pair, which is 1, 1. See here that shows that x is equal to 1. And your second component shows that y is equal to 1. And there's absolutely no difference between an ordered pair for an equation or an inequality. You just plug them right in. Okay, so you have x minus 8y is less than or equal to 9, and you have -7x plus 5y is less than 4. Place our x with 1 and y with 1. That gives us 1 minus 8 times 1 is less than or equal to 9. We go ahead and simplify this one. That gives us 1 minus 8 is less than or equal to 9. Add 8. No, not really add 8 to both sides, but if we simplify the left side, we have -7 is less than or equal to 9, which is true. Okay, now we do the same thing here. We replace x with 1 and y with 1, so -7 times 1 plus 5 times 1 is less than 4. -7 times 1 is -7, plus 5 times 1 is 5, is less than 4. -7 plus 5 is -2, so you have -2 is less than 4, which is true. Okay, so just like with a system of equations, as long as both are true, then your ordered pair is a solution. Okay, so both are true. So we know that the ordered pair 1, 1 is a solution. To the system. Okay, so now we're going to look at graphing a linear inequality or a system of linear inequality. Okay, so doing that, it helps to know these steps. Okay, so your first step is you want to graph each inequality as an equality. So in other words, your less than, greater than, less than or equal to, or greater than or equal to, you're going to solve them by replacing them with an equal sign. Okay, now here's the thing you want to remember. If you're using less than or greater than, then you're going to make your graph with a dotted line. If you're using less than or equal to or greater than or equal to, you're going to graph with a solid line. Okay, now your second step is you're going to pick a test point from each section and plug into the original inequalities. Okay, now you want to test all the sections just to make sure there's not more than one group of solutions. Okay, now your third step is once you pick your test sections, you want to shade in the test sections with true solutions. Okay, so both would have to be true in order for it to be a solution. Okay, so if you still have to write this, feel free to press pause and continue writing. But for right now, we're going to go ahead and go to our first example, at least for graphing. Okay, so what if we wanted to find the solution to the system, well, say by graphing? Okay, so if we have y is greater than or equal to negative 3x plus 1, and y is greater than negative 1/2 x minus 2. Alright, so remember your first step, you're going to graph with the equal sign. Okay, so you're going to replace greater than or equal to and greater than with an equal sign. Alright, so let's say if we go ahead and make our table. You don't have to use a table, but I just like the nice order that comes with using a table. Okay, so again, we have our x and y, and our x and y. This will be for y is equal to negative 3x plus 1, because remember, we're replacing the inequality. And this is for y is equal to negative 1/2 minus 2. Okay? Now, the original inequality is greater than or equal to. So for this one, you're going to graph with a solid line, since it's greater than or equal to originally. Okay, and this, by it being greater than, you're going to graph with a dotted line. Since it's greater than originally. Uh-oh. Okay, so just because you replace with the equal sign, you still have to be conscious of whether or not you're going to graph it with a solid line or a dotted line. Okay, one way to remember it is to remember if there's a solid line underneath, you're going to graph it with a solid line. If there's no solid line, then there's no solid line in the graph. Okay, so that's just one way to remember it. All right, so now to graph our x and y, we pick any x value and solve for y, so we can make x equals 0 and x equal -1, just to pick any values. Okay, now when x is equal to 0, you have -3 times 0, so that disappears, that just becomes 0, so y is equal to 1, which gives you the ordered pair 0, 1. Okay, when x is equal to -1, okay, you have -3 times -1, which is +3. +3 plus 1 is 4, so you get 4. Okay, so you get the ordered pair -1, 4. Okay, so remember, to graph a linear equation, you only need 2 points, and you just connect them from there. Alright, so now with this one, we can go ahead and make x equals 0, let's say x equals -2. Any 2 points, you could have picked 1. Oh, got my x. There we go. Okay, so again, if we plug in x equals 0, -1/2 times 0 is 0, so that disappears. So you end up with y equals -2. So we have 0, -2. And if we pick y equals -2 here, and I picked -2 for a reason, because -1/2 times -2, those cancel out to become 1. So you have 1 minus 2, which is -1. So you have the ordered pair -2, -1. Let me clean that up a little bit. There we go. Okay, so in order to graph, we have our 2 points for our first equality and our 2 points for our second equality. Go ahead and graph it on the next page. Feel free to press pause if you're still writing. Alright, so we have my graph already made up. Okay, so we know that we have to plot our points. So remember, for y equals -3x plus 1, we have the point 0, 1. So 0, 1 is right there. And we have the point -1, 4. Okay, so you have -1, 4, which is about right there. Alright, so again, we get our straight edge. Any straight edge, if you have a ruler or a book or postcard or anything like that. Unless you're using an online program, then you don't have to worry about it. But if you're doing it the old-fashioned way, by hand, you just get your straight edge and connect it. Alright, so that is our y equals -3x plus 1 graph. Okay, so now we get our 2 points for our y equals -1/2 x minus 2. Remember, that was 0, -2. So you have 0, -2, which is that point right there. And you have -2, -1. Okay, so you have -2, -1. Right there. Okay, so once again, we get our straight edge. And we draw right through those 2 points. And straighten it up just a little bit. There we go. Excuse my little mishap right there. There we go. Okay, so that gives us a y equals negative 1/2 x minus 2. Alright. So now all we have to do is do our third step. Oh, and I'll always forget that because this is supposed to be dotted. So that's why it usually helps to rewrite it if you're changing pages. Your original equation. Okay, so since this is supposed to be dotted, just erase out the little lines there. There we go. And again, it usually helps to rewrite your original y is greater than or equal to negative 3x plus 1, and y is greater than negative 1/2 x minus 2. Okay. If this were on the same page, it would have been easy to remember because I would have seen my little notes at the bottom, but when you switch over to different pages, sometimes you will forget. But as long as you get it before you start, you're okay. Okay, so now we go to our test points. So our third step, we have to pick a test point from this area, this area, this area, and this area. Okay, so we'll call this test point 1, test point 2, test point 3. Remember, the test point is that entire section to the left of this line and below here. Okay, it doesn't stop at the XY axis, that entire section. And this is test point 4. Now let me go ahead and cover that up a little bit. Alright, so now we're going to look at our test point 1. Test point 2. Test point 3. And test point 4. Oh, let me clean that up a little. There we go. Now, for test point 1, remember that's anywhere in this whole section. Okay, so we'll pick something easy like 1, 1. Okay, you don't want to pick anything. You can pick any value. You can pick 20 and 2 million if you want to, way over there. But picking 1, 1 is usually easiest. Excuse me. Okay, now this just shows us that x is equal to 1 and y is equal to 1. Okay, so if we plug it into our first equation, which is y is greater than or equal to negative 3x plus 1, that would just become 1 is greater than or equal to negative 3x plus 1. Okay, so all we did was plug it into that original first equation. Okay, so you have 1 is greater than or equal to negative 3 times 1 is negative 3 plus 1, or 1 is greater than or equal to negative 2, which is true. Okay, and if we do our second inequality, you have y is greater than negative 1/2 x minus 2. So that gives us y, so that's 1 is greater than negative 1/2 times 1 minus 2. Okay, which is 1 is greater than negative 1/2 times 1 is negative 1/2 minus 2. So that means that 1 is greater than negative 1/2 minus 2 is negative 5/2, which is true. Okay, so by both of those being true, that means we shade in the section with 1, 1. Okay, so since 1, 1 is right here, we shade in this entire section. Alright, and I'm not going to spend too much time shading, just to give you the general idea. Okay, now, normally as soon as you find the shaded in section, you can stop. But I always tell people to pick test points for the other sections just to be on the safe side. Okay, so for test point 2, whenever possible, I pick 0, 0. So 0, 0 falls in test point 2. Okay, so 0, 0. Okay, so again, plug in here, you have x equals 0, y equals 0. So once we plug it into our first inequality, you have 0 is greater than or equal to negative 3 times 0 plus 1, which means 0 is greater than or equal to negative 3 times 0 is 0, so that disappears. So 0 is greater than 1, which is false. Okay, so as soon as you get a false, you automatically know that's not part of the solution. So the area with 0, 0 will stay unshaded. Okay, now test point 3, you have, let's say, negative 2, negative 2, since it's about right there. So negative 2, negative 2. So that's in the test point 3 area. So negative 2, negative 2. Okay, so that means you have negative 2 is greater than or equal to negative 3 times negative 2 plus 1, which gives us negative 2 is greater than or equal to 6 plus 1, or negative 2 is greater than or equal to 7, which is false. So once again, we know that that's not a part of our solution set. Now test point 4, you can pick the point 4, negative 4, since it's about right there, give or take. Or you can pick 4, negative 5, doesn't matter. We'll pick 4, negative 5. Okay, so 4, negative 5. Okay, so x is equal to 4. Y is equal to negative 5, so that's negative 5 is greater than or equal to negative 3 times 4, plus 1. So that's negative 5 is greater than or equal to negative 12 plus 1. Or negative 5 is greater than or equal to negative 11, which is true. So now you have to test the second, because remember, both have to be true in order for that area to be shaded in. Okay, so that means if you have negative 5 is greater than negative 1/2 4 times 4 minus 2. Okay, so that gives us negative 5 is greater than negative 1/2 times 4 is negative 2, so negative 2 minus 2. That means that negative 4 negative 4. Negative 5 is greater than negative 4, which is false. Okay, so since both of them are not true, we know that this is not a solution. Okay, so we know that every value in this area will be a solution to this system right here. So if you wanted to pick 4, positive 4, it would be a solution to both of those. If you want to pick 2, 3, it will be a solution to both of those. If you want to pick 2, negative 1, it will be a solution to both of those. Everything in this shaded area would be true for that system. All right. Okay, so now we're going to look at inequalities and story problems. Okay, so what if we wanted to solve a system of linear inequalities, or use a system of linear inequalities for our story problems? Okay, now quick note that if you see the words less than, fewer than, or something that pretty much means the same thing, you're going to use the less than symbol. If you see the words greater than, more than, or something that means the same thing, you're going to use the greater than symbol. Now, if you see no more than, or at most, you're going to use less than or equal to. And if you see the words at least, or no less than, you're going to use greater than or equal to, or something similar to those. Like sometimes it won't be those exact words, but the idea behind it will mean the same thing. Alright, so let's go ahead to our first word problem example. Okay, so let's say, for example, Sam needs to eat at least an extra 800 calories to prepare for a marathon. He has $5 to spend on extra food. He chose to spend it on $1.40 burgers that have 240 calories each and 50-cent cookies with 160 calories each. Write a system of inequalities model. Okay, so they want us to create the system of linear inequalities based on the information that we have right here. Okay, so the first thing we want to do, we want to identify our unknowns. Okay, so we're going to let B equal the number of burgers. And we'll let C equal the number of cookies. Okay, now for the most part, you can usually pick your own variable, but in some cases, they will tell you which variables to pick. So they may tell you to use X and Y or B and C. But if they don't tell you, then you use your own. Okay. Now the one thing we know, well, not one thing, but one of the things we know is that the calories from the burgers he eats plus the calories from the cookies that he eats has to be at least, remember that at least, so at least greater than or equal to 800. That means you can be at 800 calories, but that's a bare minimum. It has to be at least 800. Okay, so if we wanted to set up our equation, we know that the calories from burgers, the burgers have 240 calories each. So that's 240 calories times however many burgers you eat. So if you eat one burger, it's 240 times 1, 2, you get 240 times 2, 3 burgers, 240 times 3, and it keeps on going. Okay, so plus, say the calories from cookies, we know they're 160 calories each. So it's 160 times however many cookies you eat. So it has to be greater than or equal to 800. Okay, so this actually gives us our first inequality. All right, so now we look at our second inequality. We know that the amount spent on burgers plus the amount spent on cookies has to be less than or equal to $5. Because remember, that's all he has to spend on the extra food. Okay, so we know that the burgers cost $1.40 each. Okay, so 1.40 times however many burgers you eat, we don't know yet. That's an unknown. Plus the amount spent on cookies. Cookies are 50 cents each. So you have 50 cents, or 0.50 times the number of cookies that you buy, has to be less than or equal to $5. Okay, so that actually gives us our second inequality. Okay, so all together, we have the system 240B plus 160C is greater than or equal to 800. And we have 1.40B plus 0.50C less than or equal to 5. Okay, remember, they didn't want us to solve anything or graph anything. They just wanted us to come up with the system model, which is this right here. Okay, so if you're still writing, please feel free to press pause. We're going to go to our next example. Okay, so for this example, you have an artist sells her drawings. She wants to sell at least 60 drawings and has portraits and landscapes. Okay, she sells portraits for $15 and landscapes for $10. She needs to sell at least $800 worth of drawings to make a profit. Will she meet her goal if she sells 20 portraits and 25 landscapes? Okay. If you're still writing, feel free to press pause. But right now, we're going to go ahead and solve this one. Okay, so now, just like before, we identify our unknowns, because remember, we have to create our system first before we can plug anything in. Okay, so what if we let P equals the number of portraits she has to sell, and we let L equal the landscapes to sell. And I'll make this a capital P, since we have an uppercase L there. Okay, now remember, they said she wants to sell at least 60. Okay, so if she wants to sell at least 60, then that means the number of portraits plus the number of landscapes has to be greater than or equal to 60. Okay, if she sold 60, great. But if she sold more than 60, she'll be very happy with that too. So it has to be greater than or equal to 60. So that's our first equation. Now, if we look at it this way, you have your money from portraits plus the money from landscapes. Actually, let me separate that so you know we're kind of starting something new. Has to be greater than or equal to $800, because remember, the amount of money she makes has to be at least $800 for her to make a profit. Okay, so for that to be at least $800, the money from the portraits, remember the portraits she sells for $15 each. So you have 15 times however many portraits she sells, plus the landscape she sells for 10. So you have 10 times however many landscapes she sells, and that has to be greater than or equal to 800. So we have our second equation. All right, so we have our first and second equation, inequality. I'm used to saying equation, so that should be inequality, since it's not an equal sign. So, and inequality. There we go. Okay, so that means we have the system. Move that up a little bit. You have P plus L is greater than or equal to 60, and 15P plus 10L is greater than or equal to 800. Okay, so we have our things there. Okay, so now we replace P with 20, because remember, if she sells 20 portraits and 25 landscapes, will she meet her goals? Well, we're just going to plug in P equals 20 and L equals 25. Alright, so we're running a little short on space here, so we'll continue this on the next page. If you're still writing, feel free to press pause. But we're going to continue this. Okay, so just rewriting P plus L is greater than or equal to 60, and 15P plus 10L is greater than or equal to 800. And remember, we had P equals 20 and L equals 25. Okay, so if we replace P equals 20 here, P plus L greater than or equal to 60. 15P plus 10L is greater than or equal to 800. All right, so now we are going to look at P equals 20, so you have 20 plus 25 is greater than or equal to 60. Okay, so 20 plus 25 is 45, so 45 is greater than or equal to 60, which is false. We don't even have to do this one. Because if she sells 20 portraits and 25 landscapes, she did not sell a minimum of 60 drawings. Okay, now if this would have been true, then we plug it in here. That would have had to be true also. But if both of these would have been true, then that means that, yes, 20 and 25 would have been okay. But because this one's false, she didn't sell at least 60, we know that that wouldn't work. So selling 20 portraits and 25 landscapes will not meet her goal. Alright, so hopefully these examples made sense to you, and I will see you on the next video.